So in this video, we'll be looking at some properties involving negative exponents or some problems involving negative exponents, just to make sure that we're getting real comfortable with these negative exponents. So a problem like this where it says 1 over 3 to the negative second power, well, another way to write 3 to the negative second power is 1 over 3 to the second power. So that really means this could be 1 divided by 1 over 3 times 3, which is 9. To simplify that, that would be 1. Oh, if you remember how to divide fractions, you change flip. So keep the 1, which was on top, change the division to multiplication, and flip the 1/9 to 9 over 1. So 1 times 9 is 9. Another way to think about this is simply, instead of going through all that, just move this up. So that would just be the same as 3 squared. You change the levels, you change the exponent. 3 squared is 9. All right. So sticking with the idea of moving it up, let's try to do this problem with just moving the variables up or down based upon if they have a negative exponent. But first, numbers with numbers. 20 divided by 5 is 4. Now if you notice, the 20 is in the numerator. The 5 is in the denominator. Since the larger number was on top, we keep the 4 on top. X to the 5th here, this is negative. So let's move x to the 5th down here. The x to the negative second, oh, we have another negative exponent, so we'll move that to the numerator. Y to the negative second comes down as y to the second. And y to the 4th, since the exponent was positive, leave it right where it was. Now we're ready to simplify. Again, we're thinking numbers with numbers, a's with a's, b's with b's, etc. So we have 4 on the top, and we have x to the second and x to the 5th, which would be x to the negative 3rd. That's if you put it in top. But clearly you can see x to the second, 2 of those x's would cancel, leaving you x to the 3rd in the bottom. So we could think about it like that. And in the bottom also, y to the second times y to the 4th. Keep the base, add the exponents, y to the 6th power. Moving on to the third example. First, let's take care of the fact that we have a product raised to a power. So this is going to be 2 to the 3rd power, as we've seen before, times x to the 3rd power, times y to the negative 3 times 3, which would be y to the negative 9th power, divided by 4 to the negative 4th power, x to the negative 4th power, and y to the negative 8th power. Now keep in mind, this is not the only approach to this problem. We could have approached it slightly differently, moving this whole thing up top, but that's the way I chose to do it. 2 to the 3rd power, we know, is 2 times 2 is 4 times 2 is 8. We have x to the 3rd up here. We have, so we'll leave it since it was a positive power. Everything else is a negative power, so we'll have to shift it. So this 4 to the negative 4th power, well, 4 to the 4th is 256, but it'll have to come up to the top. So times 256. The x to the negative 4th can come up top as x to the 4th. The y to the negative 9th power can go down as y to the 9th, and the y to the negative 8th can come up top as y to the 8th power. Again, not the only way to do the problem, but certainly one way. Basically, I dealt with the positive exponents first, left them on the same level, either the top or the bottom, and then dealt with all the negative exponents. So 8 times 256, we're multiplying numbers times numbers on the top, 2048. Over here I have x to the 3rd times x to the 4th, which would be x to the 3 plus 4, x to the 7th power. And the y to the 8th divided by y to the 9th would be y to the negative 1st if I put it in the top. Or if you think about it like this, since the y to the 9th, there was more y's in the bottom to begin with. So when you cancel out, you're left with y to the 1st in the bottom. So this would be 2048 x to the 8th over y.